Hey guys, I'm back with the second video on the video series on electricity class 10th science, and in this video we are going to learn about Ohm's law. Exactly. Now that's like the law in electricity. It's a very important law, very basic concept of electricity, so you shouldn't miss it out. Yeah, not just the law, we will also talk about the limitations of Ohm's law, the concept of resistivity, and most importantly, we will also solve some numericals based on Ohm's law. So that sounds interesting, and therefore you must watch the entire video because the numericals will come towards the end. So let's get started. Ohm was a scientist who performed an experiment, and from his experimental observation he found that as the potential difference between the ends of a conductor increases, the current flowing through the conductor also increases. So he said that the current flowing through a conductor is directly proportional to the potential difference applied between the ends of the conductor, provided temperature remains constant. So what he actually did, he had set up a circuit, and he kept on increasing the potential difference between the ends of the conductor, and he kept measuring currents for different values. Then he plotted a graph where he took voltage along the x-axis and current along the y-axis, and he found that the line which was obtained was something like this, which showed that current is directly proportional to the potential difference. So this means if you want to convert this proportionality into an equality, you should bring in picture a constant. So this current was equal to 1 by R into V. This constant was introduced. So from this it was written as V is equal to IR. So V is equal to IR became the mathematical expression of Ohm's law, where R is the resistance of the conductor. So resistance was a new property which was introduced from here. So what is resistance? Let us look into that now. Resistance, as the name suggests, it resists the flow of current. It opposes the flow of current. So if you have if for example we say that metals are good conductors of electricity, that itself means that the resistance of metals are very less. So if the resistance is less, the amount of current flowing will be more. If the resistance is more, then the current flow will be less. For example, in case of insulators, the resistance is more, therefore the amount of current flowing through insulators is less. Right, let us look at this picture. Here if you see, these are the free electrons which are carrying current. Now since there are so many atoms present inside it, so these electrons are facing obstructions several number of times. So therefore in this case, this is known as resistance. So look at this picture which will give you an idea of high resistance and low resistance. So if you look at this figure, here you see that the movement of this free electron is little smooth because it is not colliding, or it is not getting hit by any other atoms. So here relatively the resistance is less. Now if the resistance is less, the amount of current flowing will be more. Whereas in this case, the free electron is getting hit or getting collided by so many atoms. As a result, the resistance in this case is more. So wherever you have more resistance, the current flow will be less, and vice versa. Right? So now let us see what are the factors on which resistance of a material depend. The first one is length of a conductor. So greater the length of a conductor, more will be the collision, because as you saw in our last slide, if the length of the conductor is more, if you see, if this is my conductor, so if the length of the conductor is more, that means the free electron will experience more and more collision. So more collision means more resistance, right? So that means resistance will increase with increasing length. So we can say that resistance is directly proportional to the length of the conductor. Next one is cross-sectional area of the conductor. So similarly for cross-sectional area also, now if you increase the cross-sectional area of the conductor, what will happen? Again, let us look at this slide. Let us suppose now if I increase the cross-sectional area, That means this area, if I increase, if this width is increased, what will happen? The number of collision will decrease because the number of atoms will remain the same. If you increase the cross-sectional area, that will not increase the number of atoms. The number of atoms will remain the same, but we are adding up some extra space. Therefore, the collision will reduce because the free electrons will get some extra space to move about freely. So, the collision will reduce. So, we can say that resistance is inversely proportional to area. If you increase the area, the resistance will decrease. It is something like this. Let us suppose if this is the length of a conductor. In this length, you have these many atoms. So that means the free electron will collide with these many atoms. Now, if you increase the length of the conductor, so when you increase the length of the conductor, the number of atoms will also increase, right? Therefore, the number of collisions will increase. Therefore, resistance will increase. Now, let us suppose instead of increasing the length, if you increase the cross-sectional area. Now, increasing the cross-sectional area will not increase the number of atoms. So, the number of atoms are still the same, but now this free electron will experience lesser collision. So, therefore, the resistance will decrease with increase in area. The third one is the nature of material of the conductor. So, value of resistance is also dependent on the nature of material of a conductor. Next is temperature of the conductor. So, how does it change with temperature? When the temperature increases, what happens? For any object, if you increase the temperature, particles of that object will start moving randomly. So, they will be set in random motion. So, whenever there is random motion, there will be more collisions. So, wherever you have more collision, the frequency of collision will also increase. Now, if the frequency of collision increases, what will happen to your resistance? The resistance will also increase with the increase in temperature. So, from this, we can say that the expression for resistance can be written as rho is directly proportional to L by A, because it is directly proportional to length and inversely proportional to A. Again, to remove this proportionality, we will introduce a constant called rho. And what is this rho? This rho is known as specific resistance. What is rho? It is known as specific resistance, or sometimes it is also known as resistivity. This specific resistance is specific of a material. That means the value of rho depends on the material of the conductor. Right? So, value of resistivity is specific to every conductor. So, if we are talking about a metal, the value of resistivity will be very low. If we are talking about an insulator, the value of resistivity will be very high. So, resistivity is a constant which is often defined as resistance of unit length and unit area. So, that is how we define specific resistance. So, it is something, it is constant for a specific material. Okay, so this is how we express resistance of a conductor. Resistance is given as rho into L by A. Now you might ask that how does the dependence of resistance on temperature taken into account in this case? Well, the dependence of resistance on temperature is not exactly taken into account in this case. However, that has been observed experimentally that in case of metals or insulators or semiconductors, the resistance changes with change in temperature. So, you will study about the dependence of resistance on temperature in your higher classes, because that involves some other concepts as well. So, we will talk about that in class 12. So, for now, you should know that this is how we express resistance, and these are the factors on which resistance of a substance depends. Now, we studied Ohm's law, but do you think that Ohm's law is a foolproof law, or there are certain limitations of Ohm's law as well? Yes, there are certain limitations of Ohm's law. Ohm's law is not universally true for every object. When we look at the behavior of diodes, I am not sure if you are aware of what are diodes. They are also a kind of electronic element which allows flow of current in one direction. So diodes are those devices which allow unidirectional flow of current. You will study about diodes also in class 12, but for now you should, this is just for your information, that when you plot the VI characteristic, that is when you plot the voltage current graph for diodes, you see that instead of a straight line, you get a curve like this. So this shows that Ohm's law is not true for diodes. Similarly, in case of this compound called gallium arsenide, it is seen that the Ohm's law doesn't hold true. Again, for water voltameter, it is seen that when the voltage, this graph is often known as VI characteristic. This is often known as, the name of this plot is VI characteristic. So when the VI characteristic of water voltameter is also plotted, it is seen that it doesn't follow Ohm's law. So in case of water voltameter, it is seen that when you plot this voltage versus current, you get a graph like this instead of a graph like this. So the Ohm's law is not true in this case also. So that these were some of the limitations of Ohm's law, that it was not true for everything. Now, on the basis of whatever we studied so far, what all did we study? We studied what is electric current, what causes electric current, who carries electric current, and Ohm's law. This is all that we have studied so far. So let us try to solve problems based on all these concepts. So here comes problem number 1. It says a copper wire has a diameter of 0.5 millimeters and resistivity of 1.6 into 10 to the power minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohms? Okay, another thing which I missed to mention is that what is the unit to measure resistance? SI unit to measure resistance is ohm, which is denoted by this symbol. This is the symbol to denote ohms. Okay, so now in this case, the diameter of the wire is given as 0.5 millimeter. Resistivity, that is the specific resistance, rho, is given as 1.6 into 10 to the power minus 8 ohm meter. What will be the length of the wire to make its resistance 10 ohms? Right? So let us solve the first part of the problem. It says what will be the length of the wire. We have to calculate the length. Now from the expression of resistance, we know that R is equal to rho L by A. So from this we can say L is equal to RA divided by rho. So we can put the values of R into A. What will be A? If diameter is given as 0.5 millimeters, that implies that area will be equal to pi R square. So R will be nothing but diameter by 2 because R is the radius. So this will be pi d by 2 whole square. Right? So this will be equal to pi is 3.14 into d by 2. What is d by 2? 0.5 divided by 2. So 0.25 into 10 to the power minus 3 whole square divided by rho, that is 1.6 into 10 to the power minus 8. So this comes out to be 122.72 meters. So this should be the length of the wire to make its resistance 10 ohms. Now let us look at the second part of the problem. The second part asks how much does the resistance change if the diameter is doubled. So we have to calculate the new resistance. So let us suppose the new resistance is R dash. So we have to calculate the new resistance when it is told that the new diameter is doubled the earlier diameter. So D dash becomes equal to 2D. That is equal to 2 into the initial diameter was 0.5 millimeter. So that is equal to 1 millimeter, which can be written as 10 to the power minus 3 meters. So this is my new diameter. So therefore, the new resistance will be equal to rho L divided by A dash. Now here the diameter is doubled, so this will not affect the length at all. So this becomes equal to, what is rho? Rho is 1.6 into 10 to the power minus 8. What is L? L has been calculated as 122.72 0.72 divided by A dash would be equal to pi R dash square. So pi R dash would be pi D dash by 2 whole square. So this is equal to 1.6 into 10 to the power minus 8 into 122.72 divided by 3.14 into 4 into d dash square, that is 10 to the power minus 3 whole square. So this value comes out to be 2.5 ohms. So this would be the value of the new resistance if the diameter is doubled. Let us look at the next problem. It says that the value of current flowing in a given resistor for the corresponding values of potential difference V across the resistor are given below. That means the potential difference was changed from 1.6 volts to 3.4 to 6.7 to 10.2 and so on, and the corresponding values of current flowing through the conductor was also noted down. So plot a graph between V and I and calculate the resistance of that resistor. So first of all, let us try to plot the graph. So we take V along x-axis and we take current along y-axis. So let us say this is the origin. This is 2, 4, 6, 8, 10, 12, 14, and along y-axis I take 1, 2, 3, 4. So the first value of voltage is given as 1.6. So 1.6 would be somewhere here, and for a value of 1.6 the amount of current is 0.5. So 0.5 will be somewhere here and 1.6 will be somewhere here. So this is the point. The next one is 3.4 voltage. So 3.4 would be somewhere here and current is 1 ampere somewhere here. Next is 6.7 volts. So 6.7 would be somewhere here and this current is 2 amperes. Again, next is 10.2, that is somewhere here, and the current is 3 amperes. Then you have 13.2 and the value of current is 4 amperes. Now if you join these points, what do you get? You get a straight line. So this shows that current is directly proportional to voltage. Now you have to calculate the resistance of the resistor. Now from Ohm's law, we know that V is equal to IR. So we can say that resistance is equal to V divided by I. So looking at this graph, you can take any point, take any of these points. There are a total of 5 points. Now take any of these points. Let us suppose if I take these points. So what are the values of current and voltages here? What is the value of voltage here? For this point the voltage is 6.7 volts and current is 2 amperes. So if we take these values, what would be the value of voltage? That is 6.7 and current is 2. So the value of resistance comes out to be 3.3 ohms. So this would be the value of the resistance. So not only this point, if you take any point on this straight line, the value of the resistance will come out to be same because it is a straight line. So the slope of this line will remain the same everywhere. Let us look at the third problem. It says when a 12 volts battery is connected across an unknown resistor, there is a current of 2.5 milliamperes in the circuit. Find the value of the resistance of the resistor. So what is given here? A battery of 12 volts. That means this 12 volts battery is capable, this battery is capable of producing a potential difference of 12 volts. Right? I told you before also that potential difference is created by, it is generated by cells or batteries. Right? So what is the amount of current that is flowing through the circuit? That is 2.5 milliamperes, which can be written as 2.5 into 10 to the power minus 3 amperes. So we have to calculate the value of the resistance. So using Ohm's law, we can say that V is equal to IR. So from this we can say R is equal to V by I. that is equal to 12 divided by 2.5 into 10 to the power minus 3. So this comes out to be 4.8 into 10 to the power 3 ohms, that is equal to 4.8 kilo ohms. So this would be the value of the resistance of the resistor.
I hope this video on electricity was useful. If you have a feedback to share, do let me know in the comment section. I would be very happy to hear from you. If you like the video, do not forget to share with your friends so that they can also learn from this video. I will see you all very soon with a new video, with a new topic. Till then, stay home, stay safe, take care. Bye-bye.